And welcome to the tutorial for Chapter 5, Section 1, Intro to Valuation, the time value of money. In this case, we will be focusing on the future value and compounding. Before we get going, let's define the term future value. Future value is the amount of money an investment will grow to over some period of time at a given interest rate. It is also defined as the cash value of an investment at some time in the future. To put this into a concept we understand a little easier, let's consider an investment of $100 made today. If our investment earns 10% over a period of 5 years, the future value would be the amount of money we have at the end of the 5-year investment period. Let's begin by looking at a concept called single period investing. Single period investing takes into consideration an investment made today that is going to grow for a single period. In this case, we are investing $100 in a savings account that pays 10% interest per year. If this $100 is left in our savings account for 1 year, how much will we have at the end of the first year? To arrive at the answer, we utilize the formula investing times 1 plus the interest rate. In this case, our investment is $100 and our interest rate is 10%. So our formula is $100 times 1 plus 10%. When worked, we arrive at an answer of $110. This is the amount that we would have 1 year from today if we invested $100 in a savings account today, earning 10% interest. The next concept we need to consider is one called multi-period investing. Multi-period investing takes into account an investment made today for a time period of more than 1 year. In this case, let's consider the same $100 invested at 10% interest, but our investment stays in our savings account for 2 years rather than 1 year. How much would we have at the end of the second year? To arrive at our answer, we utilize the same formula we did in the single period case with one slight variation. When we arrive at the second year, our investment is now $110 rather than $100. The reason for this is something called compounding. Compounding is defined as the process of accumulating interest on an investment over time to earn more interest. It's also known as interest on interest, which means interest that is earned on the reinvestment of previous interest payments. To get a good understanding of what interest on interest is, let's consider example 5.1 in your text. Suppose you locate a 2-year investment that pays 14% interest per year. If you invest $325, how much will you have at the end of 2 years? As you see on this timeline below, year 0 represents your investment today. As the problem stated, we are earning 14% interest per year over the 2-year investment. The question mark represents the amount of money we will have at the end of our 2-year investment, which is also known as our future value. To calculate the answer to this problem, let's turn to our calculators. And if you haven't yet watched the tutorial for the use of your calculator, it's highly recommended that you do so at this point. We begin by considering what we are trying to calculate. In this case, we know that we're solving for our future value. So let's consider what we have been given. We know that we are investing $325 today into a savings account. We also know that our investment will remain in our savings account for 2 years and earn an interest rate of 14%. Since we are making a single investment and letting our investment sit in our bank accounts for 2 years, we are not making any additional payments, so our payments will be zero. Taking into consideration all of these factors, we arrive at a future value of $422.37. Another way to arrive at an answer for the future value of our investment is to utilize the tables in the back of the book. Table 1A is titled Future Value of $1 at the End of T Periods. This table can be used to derive the future value of a lump sum investment. To utilize this table, we have to consider the interest rate we are going to receive and the time period we are investing. In this case, we are going to receive a 14% interest rate for 2 periods. If we find 14% across the top of the table and follow it down 2 periods, we find what is known as the future value factor. This is a factor that is to be used against the initial investment. So for example, we find that the factor to be used in this case is 1.2966. Sorry, 1.2996. This factor is to be multiplied by our initial investment of $325 to arrive at a future value of $422.37. This graph demonstrates the breakdown between interest earned by utilizing simple interest as well as utilizing compounding interest. We see in the graph that we are earning 10% interest on an investment of $100. We find that the first year we earn 10% on our initial $100 investment. All $10 is applied to simple interest. However, we find that at the beginning of the second year, we start with an investment of $110, which is the $100 initial investment and the $10 we earned in the first year. We find that if we earn 10% on our investment of $110, that we end year 2 with a total of $121, of which $10 is attributed to simple interest and $1 is attributed to compounding. We continue this trend until the end of our investment period, where we find that we are left with $161.05 at the end of 5 years. This graph shows the reader that as the time horizon on your investment progresses, the amount of money earned that is attributed to compounding grows exponentially, causing the ending balance to grow at a faster pace the further out into the future your investment goes. Let's consider example 5.2 in your text. Let's assume that you have located an investment that pays 12% per year. The rate sounds good to you, so you invest $400. How much will you have at the end of 3 years? How much will you have at the end of 7 years? The timeline shows that your initial investment of $400 happens today in year 0, and that you will receive 12% on your investment over a 3-year period. The question is, how much will you have at the end of 3 years? To work each problem, both 3 years as well as 7 years, we first utilize our calculators. To arrive at the correct value for an investment of 3 years, we enter our initial investment of $400, we enter our rate of return of 12%, and the term of our investment of 3 years. Since this is a lump sum investment, there are no additional payments. We arrive at a future value of $561.97. Please pause this video and try to arrive at the given answer for the 7-year investment. Again, we can derive the future value by utilizing table A1 in the back of our book, as we did previously. We find that if we find the correct rate of return of 12% and the appropriate 3-year period, we arrive at a future value factor of 1.4049, which is then multiplied by our initial investment of $400, resulting in a future value of $561.96. Please pause this video and try arriving at the given answer for the 7-year investment utilizing table A1. As we have reviewed in this section, future value is a necessary concept to understand to be able to derive the amount of money you will have at a given point in time, considering a given interest rate.